Astronomers have recently found a strange object far away from Earth. It disappears every 2 minutes and sends out waves of radio noise 3 times in 1 hour. It was first seen by a student named Tyrone O'Doherty while he was looking at the sky in his home country, Australia. This space object appears to be different from anything else we've seen before in space. Because of their calculated movements, scientists call these types of objects transients. Turns out, they are not that rare to find. When scientists study transients, most of the time, they look near a big star or near the things it leaves behind after it goes out. Transients come in all sorts of shapes and sizes. Some transients are slow, take a few days to appear, and stay around for a couple of months. Other transients are very fast and only appear for a second. But there are not many transients that are in between these two speeds. It's what makes this latest discovery very special and unexpected. Speaking of weird things we've found in the universe, the toughest object we know of is made from the remains of a star that has faded away. Scientists have found out through experiments that when the center of a faded star is squeezed by a lot of gravity, it turns in a type of spaghetti-like material that is extremely strong. Even if you could technically touch it with your hand and try to break it, you would need to use 10 billion times more force than it takes to break steel. Planets can be weird too. Haumea is a perfect example. This dwarf planet moves around the Sun far away from Earth, beyond Neptune. It's different from other planets because it's shaped like a sausage and has 2 small moons. It also spins very fast. One day on this planet is only 4 Earth hours long. In 2017, scientists saw something strange when Haumea passed in front of a star. They noticed very thin rings around it, which probably appeared when other various space objects were hitting each other in its vicinity a long time ago. Ever heard of a moon? It's a fancy name for a moon that orbits another moon. People on the internet let their creative side go wild with this one and gave it all sorts of different names, like submoon, moonito, grand moon, and moonette. This kind of object is just a theory right now, but scientists think it's possible that it might exist. Maybe someday we'll discover one. There are many strange moons in our solar system, like Io, which is very volcanic, and Triton, which has geysers. But one of the weirdest looking ones is Hyperion. This one is a rocky moon with many craters that looks like a pumice stone. A spacecraft called Cassini also found that Hyperion has a beam of static electricity flowing out from it. The reason for this weird activity is still up for debate. Not all stars behave the same either. When a scientist named Tabitha Boyajian, pronunciation here, https u2.b f8vy63um-56, and her team looked at this star called K-ICE 846285, they were confused. Also known as Tabby's star, this space object would dim unexpectedly, sometimes for as much as 22%, for random periods of time. However now, most people believe that the star is surrounded by a strange ring of dust that makes it look darker every now and then. Some galaxies are equally unusual. DGSAT I is a type of galaxy called an ultra-diffuse one. This means that it is very big, similar to our own Milky Way galaxy, but it has very few stars and is hard to spot with regular telescopes. Scientists discovered DGSAT-Y in 2016 and noticed that it was all by itself, which is unusual for ultra-diffuse galaxies. This means that DGSAT-I is very old and formed a long time ago, about 1 billion years after the beginning of the universe. NGC 247 is another weird spiral galaxy that looks almost made up. It is smaller than the Milky Way and has bright areas where new stars appear. However, there's also a dark void on one side of the galaxy's core that looks like a hole. Some theories suggest that this void could have been caused by gravitational interactions with another galaxy, or a blob of dark matter. Another theory suggests that it could be the work of another civilization building something weird in there. The Exotica catalog lists some unusual galaxies that might have big civilizations living in them. Scientists are trying to build new telescopes that will make it easier to find them. The Vera C. Rubin Observatory in Chile, for example, will be able to look at the entire sky repeatedly and see if there are any changes that could help us locate some foreign space cousins. Just in case you ever stumble upon this word, a neutrino is a particle smaller than an atom, with no electric charge and a very small mass. They are produced during nuclear reactions, such as those that occur in the sun. Neutrinos are extremely difficult to detect because they interact with other types of matter very weakly. Scientists use large underground or underwater detectors to spot neutrinos. They study their properties to gain a better understanding of the universe and its origins. On September 22, 2017, a powerful neutrino hit Earth. This kind of thing happens often, but this one was special because scientists were able to figure out where it came from. They discovered that it was sent to Earth 4 billion years ago by a very big black hole in a galaxy that was eating up everything around it. Do you think you have an impressive jewelry collection? Wait until you hear this. Astronomers have discovered a planet that is mostly made of diamond. The planet, called 55 Cancri E, is a superplanet and is located in our Milky Way galaxy. Scientists believe that at least a third of the planet's mass is pure diamond. This is the first time a rocky planet with this kind of composition has been discovered. 55. Cancri E is very different from Earth, as it has a lot of carbon and is very hot, making it unlikely for life as we know it to exist on it. We've learned a lot of things about the universe with the help of our trusted Hubble Space Telescope. One of the most famous images taken by it is called the Pillars of Creation. This is a photo of a region of the Eagle Nebula where new stars emerge rapidly. Captured in 1995, this picture allowed us to see massive pillars of gas and dust towering above the nebula, and has become one of the most iconic images of the universe. Some of your friends might even use it as wallpaper on their phones. The sun we spin around is a lone wolf. In reality, many stars in the galaxy have companions. Castor is one of these. It's a group of 6 stars that make up one of the brightest and most beautiful systems in the night sky. People have been looking at Castor for a long time, but they hadn't known it was actually 6 stars until telescopes and spectroscopes were invented. Even with a small telescope, you can see that Castor has 2 main stars, Castor Ea and Ba, that orbit each other. These stars are bigger than the Sun, and it takes them 467 years to orbit each other. Scientists from Asia found over 500 stars that are way weirder than those we've been familiar with. They move quickly around the center of our galaxy, the Milky Way. Some of these stars move so fast that they will, at one point, leave the Milky Way. The team behind the project used 2 telescopes to study these stars and properly understand their speed. These days, we call them high-velocity stars. In February 2025, scientists discovered something shocking about our planet's insides. We've long thought that Earth's inner core is a solid and stable sphere, but the truth may be quite different and a bit alarming. A recent study suggests that the surface of the core might be undergoing structural transformations right at this moment. Researchers from the University of Southern California have analyzed decades of seismic data and discovered that the surface of the inner core appears to deform under the influence of the outer core. We have observed such changes for the first time, but they are likely to explain some peculiarities in the rotation of the inner core. They could even be influencing the length of days on Earth. The inner core of our planet, located about 5,000 kilometers below the surface, is traditionally described as a solid ball of iron and nickel. However, new data shows that its outer layer may be more malleable than expected. This discovery is based on the analysis of seismic waves from repeated earthquakes near the South Sandwich Islands. The researchers used enhanced resolution techniques to study these seismic signals. They observed anomalies in the waves and made an unexpected conclusion. There must be deformations on the surface of the inner core, and they could be caused by turbulent interactions with the molten outer core. The outer core, composed of liquid iron and nickel, has a highly important role. It helps generate Earth's magnetic field. Before, we didn't really understand its impact on the inner core, but now, the new study shows that the turbulent movements of the outer core could disrupt the surface of the inner core. And that could cause changes in its shape. These disturbances might also explain the gradual slowdown in the rotation of the inner core. Scientists have been observing it since 2010. On the surface, we don't really notice these changes, but they could influence Earth's overall rotation and the length of days. This study can help us understand better what's happening deep inside our planet, how the inner and outer core interact, and how that affects Earth's magnetic field and movement. Obviously, direct observation of Earth's core is impossible. That's why scientists use indirect methods, like analysis of seismic waves. It allows us to deduce the structure and composition of the core. As these waves pass through different layers, they get deflected or stopped. And this can provide us with clues about the nature of the materials they encounter. There are also laboratory experiments. Researchers reproduce the extreme pressures and temperatures of the core and study the behavior of iron-nickel alloys. They use sophisticated instruments, such as diamond anvil cells, and they allow exploration of these extreme conditions. Then, there are studies of meteorites. The thing is, some of them come from asteroids with a metallic core, like Earth's. Their chemical composition sometimes provides clues about the elements present in Earth's depths. Scientists also create numerical models. By combining seismic, experimental, and geochemical data, they simulate the internal dynamics of the core. But what would happen if Earth's core suddenly stopped spinning altogether? It's unclear, but we can make assumptions. If it was just the solid inner core that stopped, the answer would be, not much. Even if it didn't just slow down its movement, which is happening right now, but stopped altogether, the main impact would be on the speed of Earth's rotation. Our days would get longer. Over time, it could weaken the planet's magnetic field, which would be bad news, but not as catastrophic as what would happen if the outer core stopped spinning. That's when things would get seriously bad. Without the rotation of the outer core, Earth would lose its magnetic field, and the loss of this protective shield would set off a catastrophic chain reaction. First off, tectonic plates would start colliding in chaotic ways. Imagine being on a bus when the driver suddenly slams on the brakes and you go flying into other passengers, or on the floor. The planet would experience something similar, but with tectonic plates. These violent collisions would cause massive earthquakes along plate boundaries worldwide, shaking buildings, bridges, and roads. Water systems, electricity, and phone lines would be destroyed in the chaos. But this would only be the start. Without the magnetic field, cosmic radiation would start hitting Earth's surface. These high-energy particles from the sun would interact with the oxygen and nitrogen in our atmosphere, damaging the ozone layer. This would allow even more radiation to reach Earth's surface, causing even more damage. Electronics would fail, power grids would collapse, and communication systems would go dark. But the effects wouldn't be limited to just humans. All forms of life would be at risk. Many animals, like migratory birds and turtles, rely on Earth's magnetic field for navigation. With it gone, they would be completely lost. Birds would lose their sense of direction, and turtles wouldn't be able to find the beaches where they need to lay their eggs. Luckily, we don't need to worry about this apocalyptic scenario anytime soon. The outer core of Earth is very unlikely to stop spinning in our lifetime. Or ever. So, for now, we're safe. But to truly understand Earth, you'd need to go 6,137 kilometers beneath our feet. Earth has 4 main layers, from the very center to the surface. the inner core, outer core, mantle, and crust. Except for the crust, no one has ever explored these deeper layers in person. The deepest humans have drilled is just over 12 kilometers, and that took 20 years to achieve. At the very center of Earth is the inner core, a solid metal ball about 1,220 kilometers in radius, which is about 3/4 the size of the Moon. It sits about 6,137 to 5,180 kilometers below the surface. Made mostly of iron and nickel, the inner core is incredibly dense. It spins a bit more slowly than the rest of Earth and is intensely hot, reaching temperatures of 5,126 degrees Celsius. It's like the surface of the sun. The pressure there is staggering, over 3 million times greater than the pressure we feel on the surface. Some research even suggests there might be an even smaller, denser core inside the inner core, thought to be made mostly of iron. The outer core is also made of iron and nickel, but in liquid form. It sits about 5,180 to 976 kilometers beneath the surface. The heat here comes mostly from the radioactive decay of elements like uranium and thorium, causing the liquid to churn in massive turbulent currents. This motion creates electrical currents, which generate Earth's magnetic field. Interestingly, Earth's magnetic field reverses about every 200,000 to 300,000 years, and scientists are still trying to figure out exactly why it happens. The mantle is Earth's thickest layer, stretching almost 3,000 kilometers deep. It starts just around 30 kilometers beneath the surface, made of iron, magnesium, and silicon. It's dense, hot, and semi-solid. To imagine it better, think about caramel candy. Like the outer core, the mantle also circulates, but it moves much more slowly. Closer to the upper edge of the mantle, between 100 to 200 kilometers underground, the heat is so intense that it melts rock. This creates a partially melted layer of rock called the asthenosphere, as the oosphere. Geologists think that this soft, hot, and slippery layer is what allows Earth's tectonic plates to move and slide. Some of the diamonds we find on Earth come from the mantle. Most of these diamonds form at depths above 200 kilometers. But rarer, super deep diamonds may form as deep as 700 kilometers. These diamonds are brought to the surface by a certain kind of volcanic rock called kimberlite. The outermost part of the mantle is cooler and more rigid, behaving more like the crust above it. Together, this uppermost part of the mantle and the crust are called the lithosphere. As for the crust itself, it is the outermost layer of Earth. It's about 40 kilometers deep and makes up only 1% of the planet's mass. And yet, it holds all known life in the universe. Scientists keep finding new planets they call super-Earths. It's a class of more massive planets than Earth, but way lighter than ice giants such as Uranus and Neptune. Super-Earths can be made of rock, gas, or a combination of these two. They are often twice or even up to times about weight Amran. Iris than the Earth. They're interesting to study, but kind of too far away from us. They're pretty common outside of our solar system, together with other interesting planets like mini Neptunes. Those can also be gas dwarfs, ice giants, or huge rocky bodies. But again, we don't have anything like that. But something we do have that those other solar systems don't: Jupiter. It's the biggest and heaviest object that orbits our sun. This king of planets possesses a powerful force to dominate our solar system. Jupiter is notorious for eating planets. A protoplanet slammed into it about 4.5 billion years ago, when Jupiter was still a young planet in its early stages. This protoplanet was 10 times heavier than Earth and was made of ice and rock. The collision was huge. Jupiter's core broke apart, and helium and hydrogen mixed with denser materials. Through time, the heavy material settled back into the dense core, which is what we see today. And if it swallowed a planet before, it might keep doing it as well. We suspect our solar system used to have many more large planets than it has now. For example, it's kinda empty around Mercury today. Similar areas around many other central stars are definitely more packed with intermediate mass planets. With the size between Earth and Neptune, our solar system was a chaotic place at its beginnings. Young stars were surrounded by swirling disks of dust and gas, and planets would form out of that debris, something like trees when they're springing up from the ground. Small, rocky planets would form in the strong heat and light close to stars, while gas giants would form farther out where temperatures were lower, which means they could preserve more gassy materials. And even though planets in our solar system seem pretty stable and peaceful today, following their orbit, they weren't that calm before. Some planets didn't have a circular orbit. They had oblong, more eccentric paths. It took them swinging first towards their stars. It was like they had been thrown off kilter by the gravity of other planets on their way. There's something called the Grand Tack theory. It explains things happening in the first few million years when our solar system was forming. At some point, Jupiter, one of the key players here, may have been pulled in closer by our central star. After that, it went back and took a huge cloud of debris. It was like a sailboat when it tacks around a buoy. This kind of messed with planets that were in the process of formation. After Saturn was fully formed, our close neighbors in the solar system cleared out a little. But if the idea about Grand Tack is correct, Jupiter had grabbed everything in its way, and its migrations had caused more collisions in this area. Jupiter might have delivered some of the water that now fills the oceans we have on our planet. It shepherds plenty of asteroids. From time to time, it sends some whizzing into interstellar space or amongst the planets in our solar system. It may have even taken part in the dinosaur extinction 66 million years ago. When the huge space rock hit the Earth, it left a crater off the coast of the Yucatan Peninsula in Mexico. It all caused earthquakes, volcanic eruptions. We're not even sure if it was an asteroid or a comet. One theory says it may have been a comet that came from the Oort cloud, which is made of icy debris and is located somewhere at the edge of our solar system. It could have been bumped off course by Jupiter and its powerful gravitational force. This way, our solar system was like a pinball machine, where Jupiter, the biggest planet, kicks incoming comets into orbits that send them closer to the sun. When these comets are near the sun, they can go through strong tidal forces that break them apart and eventually create shrapnel-like pieces of a comet. That event was a point when our mammalian ancestors started to rule. That means without Jupiter, there might not be us either, nor the Earth. It seemed like our biggest planet came swinging in, destroyed older planets, and cleared the way for smaller worlds like ours. Jupiter may have been the reason why we can't find Planet 9 right now. Scientists believe it exists, and they think it could be hiding somewhere beyond Neptune, but not Pluto. There are 3 zones in our solar system: the inner planets, outer planets, and whatever there is beyond. The mysterious planet could be the size of the Earth or Mars. It swirled among the gas giants before they eventually swept it toward the outer parts of our solar system, or even somewhere into deep space. Jupiter has stripes because of differences in temperature, atmospheric gas, and chemical composition. Scientists used to think the only reason for these different colors was the mighty atmospheric wind and material circulating between layers of the atmosphere. Now we know the light-colored stripes, or so-called zones, show us where the gas rises. When the stripes are dark-colored, they're called belts, and can tell us where gas is sinking. Jupiter's moons could also be why the planet is stripy, because they're tugging on its atmospheric convection cells. At the center of Jupiter, there's a dense, liquid core made of helium and metallic hydrogen, together with dissolved heavier elements. The temperature and pressure inside the planet drop off. That way, the liquid interior gives way to gases from the atmosphere. Again, mostly helium and hydrogen. No one knows how deep this liquid-gas boundary lies, but the planet is probably fully liquid a couple of thousand miles under its cloud tops. Jupiter would still be bigger than some other giants, like Saturn, if we could strip its gases. Jupiter is sometimes even called a failed star. Although it's not quite correct, It's mostly made of hydrogen-like regular stars, but it's still not massive enough to start thermonuclear reactions in its core, which would eventually turn it into a real star. In theory, every object could be turned into a star if you only add enough matter to it. If there is enough mass, the temperature and internal pressure will increase and start thermonuclear reactions. So, to turn Jupiter into a star, such as the Sun, you'd have to make it 1,000 times more massive. But to form a cooler red dwarf, you'd only need 80 Jupiter masses more. That way, Jupiter won't spontaneously become a new star of our solar system. But if many space objects with similar mass collide with it, but in theory, if it could become a massive star, it would have stopped other planets from forming in stable orbits. It would have also increased the radiation the surface of those planets gets. Jupiter is the planet that spins the fastest in our solar system. It only needs 10 hours to make a full rotation on its axis, even though it's huge, more than 300 times bigger than the Earth, and 2.5 times more massive than the rest of the planets in our entire solar system together. But if it got more massive, it would shrink. More mass would make Jupiter denser, which means it would begin pulling it in on itself. So, it could get 4 times its mass and would still be the same size. I hate to break this to you, but money isn't actually made of paper, which also proves that money doesn't actually grow on trees. Most banknotes are 25% linen and 75% cotton, which is why they have such a distinct look and feel. Back in the 19th century, money was made of parchment paper. That's why people could very easily counterfeit it, unlike now. The Eiffel Tower is almost 6 inches taller during the summer. When you heat up some substance, its particles start to move more actively and take up a bigger volume. When the temperature lowers, the substance contracts again. Such an effect is more prominent in gases, but you can also track it in liquids and solids, including iron. If you make a snowball and try to set it on fire using your lighter, the thing won't melt. The snow will first turn black, then it'll start to vanish, but you'll get no water. There's nothing supernatural about this phenomenon. The snow is melting, but you don't see it because of the structure of the snowflakes. They kind of wick away the melted water, and it gets absorbed by the remaining relatively loosely packed snowball. Our moon used to have an atmosphere. Several volcanic eruptions happened on Earth's natural satellite around 4 billion years ago. They released immense volumes of gas, trillions of tons. It was so much that the gas didn't have enough time to escape into space. That's how an atmosphere was formed. Just like a chicken egg, an ostrich egg will contain a chick embryo, only if the egg was first fertilized by a male ostrich. Otherwise, you'll find only whites and huge yolk inside of it. The size of the yolk is equal to around 24 chicken yolks. So, one ostrich egg can easily feed a squad of 10 people. But ostrich eggs aren't all that edible. Those who tried them say that they taste a lot like chicken eggs, fatty, buttery, and kind of sweet. But the flavor is more intense. They're also richer in magnesium and iron than chicken eggs, but contain fewer vitamins A and E. One ostrich egg will give you about 2,000 calories, while the average chicken egg only 75 calories. Cooking and eating them is a chore, so you'll unlikely have them for breakfast every day. Their shell is extremely thick. You can step on the eggs with both of your feet and they won't break. That's why if you want to cook an omelet using an ostrich egg, you're going to need a drill or a hammer, and also a really big skillet to fit an egg of that size. No, bigger. Yeah, like that. Boiling the egg will take almost 90 minutes. Not so long ago, scientists decided the Dinosaurs family tree had to be redrawn for the first time in 130 years. Apparently, 2 species of dinosaurs had to be grouped together from the very beginning. Those were the lizard-hipped meat-eaters, like T-Rex, and bird-hipped vegetarians, such as the Stegosaurus. People are still evolving. Scientists have been tracking several millions of human anomalies. It turns out some harmful genes are slowly but surely getting filtered out of human DNA. Sound travels almost 4 times faster underwater than it does in the air. That's why divers often have problems with figuring out the direction of sound. Bananas contain potassium, and this element is slightly radioactive. On the bright side, you need to eat 10 million bananas before radiation can negatively affect you. Meanwhile, out in space, shadows are darker on the moon than on our planet. That's because the atmosphere on Earth scatters more sunlight. But if you could visit the moon, you'd observe shadows so dark you wouldn't be able to see where you were going. Also, you'd notice fresh footprints on the lunar surface. People haven't set foot there in a few decades, but the footprints look as if they were left just yesterday. Since there's no water or wind on the moon, nothing can erase these footprints, so they can stay there in their original form for millions of years. Sure, if you were about to go to space, one of the first things you'd think of would be your spacesuit. But do you know that it's possible to survive in space even if you aren't wearing any protection? Well, don't get your hopes up yet. You'd last for no more than 15 seconds. That's how long it'd take you to lose consciousness, because oxygen will stop coming to your brain. The ocean performs many important functions. For one thing, it produces 50 to 80% of all the oxygen on our planet, which means it keeps us alive. But it also helps the internet to function. So, when you're laughing at a funny dog video or binge-watching your favorite series, Disneyland's airspace has the protection level of the White House and the Kennedy Space Center. It's prohibited to fly over the theme park without a special waiver. The restriction was introduced in 2003 for security reasons, so now you will never see a plane, or even a single drone, flying over the park. How about a butter applicator in the form of a glue stick? Butter. With this invention, making sandwiches in the morning will become so much easier. The main challenge is not to confuse it with a real glue stick. Bacon lip balm is a great addition to the butter sticks. This product is already being sold online. Imagine rubbing your lips with a piece of fried bacon before going out. Not really my thing, but tastes differ. Bananas are delicious and convenient. Thanks to their dense skin, they don't break when you carry them with you. But for some people, this natural protection doesn't seem to be enough. They don't like brownish marks on the yellow peel, especially for them, one of the main inventions of the 21st century. This is a banana suitcase. The container will protect your banana from the dangers following it everywhere. How can you get your cat to work off the money you spend on its food? Let it clean the room while you're away. Japanese engineers came up with cat duster slippers. The cat walks on the floor and rides your home of dust at the same time. But I'm not sure your pet will like this idea. Hugs are very beneficial to health. They relieve stress and help your body produce endorphins, the hormone of happiness. The image of a happy girl in Wendy's logo was inspired by the daughter of the fast food chain's creator, Dave Thomas. Wendy is her nickname. If you look closer, you'll notice her collar spells out the word mom. Whether intentional or not, it became something to mean a homely feel. The restaurant gives its guests 9:41, set as the time in iPhone's ads, isn't a random choice of numbers. In 2007, Steve Jobs first introduced the iPhone to the public after a 41-minute presentation at exactly 9:41 a.m. The first Apple logo was designed in 1976 and featured Sir Isaac Newton sitting under a tree with an apple about to fall on his head. It seemed too complex and unclear to many, so Steve Jobs wanted it replaced. Some people have a fear of technology, aka technophobia. Now it mostly has to do with complex new devices like computers, but it has its roots back in the time of the Industrial Revolution. It began in the 18th century, when workers were afraid new machines would take their jobs. The founders of Domino's were originally planning to add a dot to the Domino's in the logo for every new place they opened, but it was growing way too fast and too big for that. So they decided to keep just 3 dots for the 3 original locations. Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second. And they don't know why. Breaking news. The Earth has gone crazy. Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather's acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there'll be no proper way of telling time, except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function. And mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds. But around the equator, you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stopped since the radar systems have gone haywire. And the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually, we'll have a total communication blackout. Ships will cease to operate, and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be in danger, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we probably feel like we're always on a jet plane, going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day, so days would be around 7 hours long, as well as nights. The whole world would be flooded, except for the highest points in the tallest mountains. If that happens, humans will most likely end up there, clinging on to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters, like earthquakes, tsunamis, volcanoes, and even melting ice sheets, have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour, and as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded, and the crust will be 80% gone. If it goes on any longer, there won't be any living things around. Probably, except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move, and will eventually be distorted, and with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry? The space crew had been getting ready for the launch for over 3 years. The preparations for landing on the strange planet included gathering and studying rock samples in the Grand Canyon, exploring ancient volcano formations in the Nevada National Security Site, and looking into gas and lava vents, lava lakes, and pit craters in various locations in Hawaii. To be able to resist microgravity conditions, they learned how to walk obliquely by being strapped and suspended sideways and trying to move along walls. They had to test their limits through intensive diet and sleep regimens to make sure they'd be safe in outer space. It took them 3 days, 3 hours, and 49 minutes to reach the surface of this new world in a place called the Sea of Tranquility. They could have gone for the Ocean of Storms or the Central Bay, but they chose this place to land because it had good visibility, and it was relatively smooth and easily reachable with as little propellant as possible. One of the first things they noticed when they got there was that, well, the place kind of smelled. This may sound like the beginning of a science fiction novel, but it's actually the true story about how the Apollo 11 mission landed on the moon on July 20th, 1969. Since then, the moon has had 12 human visitors to this day. We think of it as our neighboring space buddy, but there's still much we don't know about this mysterious satellite. And that should come as no surprise, since the moon is actually always showing us the same face. That is because the Earth and its only permanent natural satellite are in synchronous rotation, which makes us think it's always permanently still. The truth is, it's not in a fixed position, and it is actually moving further and further away from the Earth each year by 1.5 inches. Believe it or not, the Earth and the Moon, although being 238,855 miles apart, deeply influence each other. While the Moon is partially responsible for the tides of the seas and oceans on our planet's surface, our Earth is actually to blame for movement on the Moon. They're called moonquakes, and they last way longer than earthquakes, some of them up to half an hour. It may look perfectly round to us on a warm summer's night, but the Moon is actually oval. The lemon-like shape is caused by the Earth's gravitational pull. Our Moon features more than footprints when it comes to traces of humans. In 1969, American astronauts left many objects on the surface of our satellite, such as 2 golf balls, a drawing by famous artist Andy Warhol, and a message from Queen Elizabeth II herself. One of the last people to walk on the Moon to this day, an astronaut named Eugene Cernan, scribbled his daughter's initials on the Moon's surface in 1972. Since it appears there's no wind or any other type of weather change there, the letters TDC could remain there permanently. It's actually possible to be allergic to the Moon. Harrison Jack Schmitt, an astronaut from the Apollo 17 mission, spent some time in a valley in the Sea of Serenity, then climbed back into the crew's lunar module, but had some moon dust on him. Just as he removed his spacesuit, he got red eyes, sneezing fits, and other allergic reactions that lasted 2 hours. Since it's so close to us, we've established that the Moon has a time zone of its own. We call it the Lunar Standard Time, but it doesn't correspond to time on Earth. To get an equivalent, the explanation is a bit more complex, but in simple terms, a year on the Moon is split up into 12 days, each one about as long as a month on Earth. Each one of these days got its name after a different astronaut who has walked on the Moon. The start date of this calendar coincides with the moment Neil Armstrong walked on the Moon. So, the lunar year 1, day 1 began on July 21st, 1969 at 02:56:15 Universal Time. Since the Moon has a very thin atmosphere, it has some pretty crazy temperatures, both hot and cold. They can go up to 200 degrees Fahrenheit. Over by the Moon's poles, however, the temperature is always at around -400 degrees Fahrenheit. Humans have tried to trace the connection between our natural satellite and the Earth for as long as we can remember, coming up with words to explain why the Moon's existence influences us so. In the Middle Ages, scientists and philosophers thought that during a full moon, some people were more likely to experience different health conditions because they saw this inexplicable connection to the full moon. People with these symptoms were named lunatics, or at times literally moon sick. People are not the only creatures living on Earth that are affected by moon cycles. Dog owners are 28% more likely to take their pet to vet emergency rooms during the full moon. You may think that's the reason why wolves have this preference for howling at a full moon, more so in popular culture, but scientists haven't been able to find any connection between wolf behavior and the lunar cycles, so it might as well just be a myth. The largest known crater in our solar system is also found on our Moon, and is called the South Pole Aitken, AYT plus Kian. This giant formation is located on the far side of the Moon and measures 1,550 miles in diameter. One of the many things we've yet to fully understand about our satellite is the unusual flashes of light that can sometimes be seen on its surface. Scientists have named these outbursts transient lunar phenomena, or TLP in short, and they have been seen all over the world for centuries. One of the first instances of TLP dates back to 1178, when monks from Canterbury claimed to have seen a flaming torch on the surface of the Moon after the sun had set. TLP does not simply mean light flashes. Reports also have detailed other unusual events, such as gas-like mists, reddish, green, blue, or violet colorations, or even the darkening of certain locations on the Moon. Is something strange happening with our Moon? Is it the beginning, or did we just start noticing it with the newer space study equipment we have nowadays? There are a lot of different theories that scientists have developed trying to piece together what can be causing these events. The unusual flashes on the Moon can be caused by anything from meteoric impacts to electrostatic activity. It's difficult to pinpoint the explanation for each event, since most of these episodes are recalled either by a single observer on Earth or from a single location. The fact that there is noticeable seismic activity on the moon can also explain why we can sometimes see unusual flashes of light on the surface of our satellite. When the moon's surface moves, it can cause different light-reflecting gases to erupt, which can explain luminous developments. Some scientists have even suggested that residual geologic activity may also be the cause. This is all the more shocking, given that we've always looked at the moon as a lifeless world. Did you ever notice that our moon can change its color? There are actually many scientific explanations for that. The moon appears to be a brown-tinted gray when you look upon it from outside of the Earth's atmosphere. When gazed upon from the Earth's surface, the moon appears to change color depending on various phenomena. The moon seen near the horizon will most likely be yellow or red tinted. The rarer blue-colored moon indicates that you're looking at our satellite through an atmosphere carrying larger dust particles. The moon can even appear purple at times, but what causes this specific hue is still up for debate. The fact that we don't know exactly if or how much water there is on the moon's surface is not the main reason why we aren't already building houses up there. It seems that radiation actually has a lot more to do with it. Recent studies have shown that the moon's surface has a radiation rate 5 to 10 times higher than that you experience on a transatlantic passenger flight. That also means it's 200 times higher than the rate on the Earth's surface. In future lunar explorations, like the Artemis project, for example, scientists need to take this into consideration not to expose the astronauts. Named after Artemis, Apollo's sister, this program aims not only to place astronauts on the lunar surface in the future, but also to build some sort of an establishment there to study the moon in safe conditions. While the project started in 2017, the first planned mission is set for launch in summer 2022, with an estimated duration of 25 days. The space object, with no crew on board, is planned to reach lunar orbit and safely return with sufficient data for the next 4-person mission, scheduled for May 2024. Artemis III, IV, and V are expected to be launched in 2025, 2026, and 2027 respectively, each with a planned duration of approximately 30 days. We're traveling through space at the speed of light. The route from Earth to the Sun at that speed will take only 8 minutes. But it would take us about 35 years to reach our destination, which is, by the way, still very fast. By comparison, a conventional rocket would take about 600,000 years to make the journey. And here we are. It's a star system suspiciously very similar to our own, and our scientists suspect that life could exist here, just like on Earth. A red dwarf, 30% the size and weight of the Sun, lies at the heart of this star system, but these are the planets orbiting the star that interest us most. The first of these is L9859b. Its size is somewhere between Earth and Mars, but it's very light. It's only half the mass of Venus. But life is impossible on this rocky planet. It's too close to the star, and it's so hot you'd burn a cake if you tried baking it on its surface. It's about 100 degrees higher than the maximum of your oven. The planet makes a complete circle around its host star in just 2 days, compared to 365 for Earth, and it gets 22 times more energy than we get from the Sun. So it's not only hot there, but there's a lot of dangerous radiation. The next planet is 2.8 million miles from its host star. That's 13 times closer than the distance from Mercury to the Sun. L9859c, and it makes a complete revolution around the star in 3.7 days. But what's interesting is that the planet is 30% bigger than the Earth and twice as heavy, so it belongs to the class of super-Earth planets. Such planets can be rich in water, ice, methane, and hydrogen. These are some of the elements that are necessary for life's existence. Many scientists believe that it's on such planets that extraterrestrial civilizations can live, but because of the great weight of the planet, it has a strong gravitational force. So these civilizations may not be able to fly into space because it's harder for them to get out of the gravitational trap of a super-Earth planet. However, life isn't possible here because the planet is still too close to the host star. And just like in our solar system, the 2 nearest planets are too hot. But the third planet looks more promising. L9859d. It's almost twice as heavy as the Earth and 50% bigger. Scientists have calculated that about a third of its mass could be water. For comparison, the mass of all water on Earth is only 0.02%. The presence of water is the main condition for the emergence of life. But we can only guess where that water might be. It could be on the surface, but high temperatures can turn large oceans into giant clouds of steam. But water can also be contained in the groundwater below the surface. Well, we can't know that for sure yet. Let's move on to the next planet in the star system. This newly discovered planet is of the Super Venus class, L98 Tau 59. It's a rocky planet, 3 times the size of Earth. The Super Venus class means that the planet is heavy enough to have an atmosphere, but the conditions there are more like a greenhouse. Different gases fill the atmosphere there. Star rays pass through them to the planet's surface, reflect off it, and rise upward. But the dense gases don't let them leave the atmosphere, so the planet gets hotter and hotter. This is the greenhouse effect that we try so hard to avoid on Earth. On top of that, the stellar wind carries water vapor and other elements from the upper layers of the atmosphere into outer space. Life cannot exist on such a planet, nor could it ever originate, just like on Earth's twin sister, Venus. So far, all the planets we've looked at are outside the habitable zone of the host star. That's the sweet spot at a perfect distance from the star. Not too close so that the planet isn't too hot and the water there doesn't evaporate instantly. And not too far away so that the planet doesn't look like a cold desert. And planets B, C, D, and E are too close to the host star. But there's another hypothetical planet EF in this star system, located right in this sweet spot. This super-Earth candidate, L9859f, is 2.5 times heavier than our home planet, so we have hopes that it's a rocky world, just like the other planets in this star system. The weight of planet F is enough to have a dense atmosphere, and the temperature on its surface should be suitable for water to exist there in liquid form. The planet makes a complete circle around its host star in 23 days, which literally means it's New Year every 3 weeks. It isn't very likely, though, that there's a civilization there that celebrates it. Indeed, the very existence of this planet is very doubtful because we still have no direct evidence. All the other planets have been discovered by the transit method. That's when we point our telescopes directly at a star and watch its brightness change. When there is a slight drop in the star's brightness, that's when a planet has passed between us and the star. Like this dot. We have a short period of time while the planet is in the background of the star to determine its size and speed. Sometimes we can observe such transits of Mercury and Venus on the solar disk. And there are at least 29 potentially habitable planets out there in distant space that can observe Earth in the same way. About 1,115 stars within a few hundred light years are perfectly located for it. Each star has planets around it, but only 29 of them are in the habitable zone. So there really could be life and an intelligent extraterrestrial civilization out there. If so, they could point their telescopes toward the sun and see a small dot pass across the solar disk, and they could have been making these observations for at least the last 5,000 years. So they could see how our civilization was born and how we evolved. Moreover, these planets are close enough to pick up our radio signals and even television broadcasts, but it works both ways. Radio signals travel through space at the speed of light. We mastered this technology about 100 years ago. So if there really is a civilization out there somewhere, we would pick up their signal too, but so far, it hasn't happened. So we have no proof of the existence of life on these planets. The discovery of a star system like L9859 is very important to us, because we're always looking for life outside of our solar system, and super-Earth class planets are even better suited for the origin of life than planet Earth itself. Such planets are sometimes called super-habitable. So, some scientists think that Earth is a good place for life, but not the best. Super-habitable planets would have to be 30% larger than Earth, and twice as heavy. This would create stronger gravity, which would make the atmosphere on the planet denser and with a higher concentration of oxygen. This, in turn, would raise the average temperature on the planet to a perfect 77 degrees Fahrenheit, so plants would thrive there. Also, stronger gravity makes the surface of the planet flatter, so there might be more oceans there than on Earth. This will make aquatic life much more diverse. The host star also plays a very important role. It should be smaller than the Sun. The bigger the star, the more of its fuel it burns. This means that the lifespan of such stars is much shorter. For example, the lifespan of the Sun is about 10 billion years, but a red dwarf can live up to 30 billion years. More time, more opportunity for the birth of life and evolution. So far, scientists have discovered 24 superabundant planets, but that still doesn't mean that there is life there for real. But some scientists believe that there are already at least 36 advanced civilizations in our galaxy besides Earth. They've searched for similar worlds on the star map. First, we find stars that look like the Sun among about 100 billion stars throughout the galaxy. Now we choose from them those that are rich in iron. Such stars burn at the perfect temperature and help the planets around them gain an iron core and become Earth-like. Now let's pick relatively young stars from this pile, because when they get older, they expand and either absorb the planets around them or burn them up. One last thing. Let's find planets in this pile that are in the habitable zone of the star. And voila! 36 worlds may be inhabited by some unknown civilization. But we won't know for sure until we get in touch with them. When you see it in the sky, it looks round, but the moon is more of an oval shape. Similar to a lemon. This shape, flattened with a bulge on each side, came out billions of years ago when extremely hot tidal forces shaped its crust. They heated up some regions more than others. Gravity from our planet has helped to exaggerate this lemon shape over time. When they were getting ready to send missions to the moon, some researchers were worried because there was a thick layer of dust on the lunar surface. They were afraid seas of dust were both soft and thick enough to swallow their lunar lander. But even though the surface there is dusty, this layer is just too thin to cause complications. Our moon certainly isn't the biggest one in the solar system. The champion here is Ganymede, one of the 79 moons circling around Jupiter. But our moon is the largest in relation to its parent planet. It has a diameter of more than 2,000 miles, which is slightly bigger than 1/4, the size of the Earth. Pluto, for instance, has a smaller moon-to-planet ratio. Its biggest moon, Charon, is almost the size of Pluto, which is why it looks like it's a double dwarf planet system. How long would a walk around the moon take you? When the Apollo astronauts were there, they managed a walking speed of approximately 1.3 Mach per hour. On average, you walk twice as fast down on Earth. The low gravitational force on the moon would give you significantly less traction on the ground. But those special spacesuits astronauts were wearing were never actually designed for long-distance hikes. In theory, you could maybe reach the speed of 3 Mach before you'd need to break into a run. At this pace, you'd travel 6,770 miles, which means making a circle around the moon in 91 days if you were walking non-stop. Why does the moon change its shape? It goes through different phases each month, starting from the new moon and gradually going to the full moon, just to do the same thing all over again, but in reverse. The sunlight hits one half of the moon at a time. This gives it a night and a day side, just like we have it here on Earth. The shape we see the moon in depends on where it's located compared to the sun. If it's directly between us and the sun, the sunlight only hits the side we don't see. That's a new moon. It appears completely dark in that phase. But when it comes to the far side of our planet from the sun, its day side completely faces the Earth. That's when we see a full moon. After the initial phase, when the moon is new, we'll see more of its surface in the sky as it orbits our planet. It's something we call waxing. The moon in this phase first becomes a crescent. The first quarter moon is when it's half full. After that, it goes into a gibbous moon phase, when it's larger than half full, but not yet full. After it reaches the full moon phase, it slowly shrinks and goes through the same phases but in the opposite direction. While up on the moon, you'd probably see human footprints there. True, no one has stepped there since the last Apollo mission in 1972, and the footsteps may stay there for many years because there are no geological activities on the moon, like earthquakes or volcanoes. There are no winds, rain, or other things that could erase these footprints. How would you get to the moon? Rockets are probably the first thing that comes to your mind, but a lunar elevator could be an even better solution, because traveling in a rocket would be a difficult, expensive, and pretty dangerous way to try to reach the lunar surface. Why would people want to go there? It's not just about craters, an amazing view of our home planet, or other unique things the moon offers. It's also full of resources like a rare form of helium, helium-3. Humans could use it in fusion power stations on Earth. We could extract some other rare elements, e.g. neodymium-2, and use them for smartphones and other gadgets. For a lunar elevator, we'd need to stretch a cable anchored to the moon's surface for 250,000 miles toward the Earth. We wouldn't be able to attach it directly to our planet because both Earth and the moon are moving, but we could terminate high in our planet's orbit. We'd have solar-powered robotic shuttles that would move up and down the cable. This is like having a conveyor belt to ferry rare and precious resources our way. The cable would be as thick as a pencil and would weigh 40 tons. It sounds expensive, but a lunar elevator would most likely pay for itself within only 53 trips. The moon is in constant motion. It rotates on its axis and circles around the Earth. And it takes the same amount of time for the moon to make a circle around the Earth and rotate once on its axis, compared to our planet, which rotates on its axis every 24 hours and makes a full circle around the sun in 365 days. So, the moon is tidally locked to our planet, which is why we always see the same side of the moon. One theory says the moon probably formed when a large Mars-sized object, Theia, from our solar system hit the Earth. They collided 4.5 billion years ago when the solar system was still in its early stage, which was pretty chaotic. If this theory is correct, around 60% of the moon is made of lighter elements that are also present in the outer layer of our planet. A lucky set of circumstances lets us see total solar eclipses from our planet. The moon is the perfect size and distance from the Earth to appear the same size as the sun when we're looking at it in the sky. When the moon passes between the sun and us, it covers the sun perfectly. Plus, you can see an impressive halo that illuminates its edges. If it were any farther from us or smaller, a solar eclipse would only look like there's a blot on the sun. Our moon contains the water that kinda jumps around. There's water there locked up in ice. Some water molecules move around the surface as the moon cools and warms during the day. The water gets stuck on its surface until the lunar midday, when the sun is above the upper branch of any of the moon's meridians. At this point, some of the water melts, heats up, and ends up in the delicate lunar atmosphere. Its atmosphere generally contains some unusual gases, including potassium and sodium. Venus, Mars, and Earth don't have these in their atmospheres. So the water stays and floats there until it gets to a cooler area. Then it settles back to the surface. There's a specific anomaly under the surface of the South Pole on the moon, a giant and an extremely dense blob of metal lodged in the mantle, and most likely, it's altering the moon's gravitational field. No one knows how such a huge blob of metal ended up trapped under the lunar surface. It could perhaps be remnants of the iron-nickel asteroid. 4 billion years ago, this asteroid crashed into the far side of the lunar surface and created this enormous South Pole Aitken crater. Our natural satellite is shrinking. Its interior is cooling, which results in the moon getting over 150 feet skinnier, just as a grape wrinkles as it's shrinking down. But a grape has flexible skin, and the lunar surface crust is brittle. That's why it breaks as the moon is getting smaller. That way it forms thrust faults. One section of crust pushes over the closest part. This has been going on for the past few 100 million years. These lunar faults are still active. They probably produce moonquakes, as the moon gradually shrinks and cools all the time. Some of these quakes are strong, maybe 5 on the Richter scale. During their orbit around the moon, astronauts took images of Ina, a quite unusual volcanic deposit. Ina is not that old. It might have formed somewhere between 3.5 and 1 billion years ago. The volcanoes on the moon were probably active during the age of dinosaurs. If only they could have invented telescopes, they'd probably have a magnificent view of lava oozing from the lunar surface from time to time. The moon has its own time zone called Lunar Standard Time. It doesn't correspond with the time on our planet. A year on the moon lasts 12 days. Each day is about as long as a month on Earth. These days got their names after astronauts who walked on the moon. The days are divided into 30 cycles. The cycles are divided into hours, minutes, and seconds. The calendar started when Neil Armstrong set his foot on the moon on July 21st, 1969, Isons 2, 5615, Universal Time. Ready to test your knowledge? Of course you are. You'll get 1 point for each correct answer. Without further ado, the sun is yellow. Do you think this is a myth? Ask someone to draw a picture of the sun, and chances are you will get a yellow or orange circle in the sky. Surprise! The sun is not really yellow. If you see it somewhere outside the Earth's atmosphere, it will look white. How come? According to NASA, the sun's temperature is the reason why it's white. The sun consists of all colors mixed together, so it appears to our eyes as white. Then, why do you think we see it as yellow or orange from Earth? Colored wavelengths, which are yellow and orange, are longer, and they're the only ones that make it far to our eyes. The other short wavelength colors sprawl in the atmosphere, and the sky looks blue to us during the day for the same reason. Meteorites are hot as fire when they land on Earth. What do you think, myth or fact? When people see a fireball around the meteorite, they think it's super hot. This is a myth. Meteorites don't immediately land on Earth. Most of them have been in space for billions of years. Space has a cold environment, just a few degrees above absolute zero cold, But don't meteorites fall to Earth in flames? How come? The fireball is actually the air in front of the meteorite. It is compressed by the super high speed of the meteorite. The outer side catches fire, but that layer is blown off on impact as a result of landing on Earth. As you would probably guess when they land, the meteorites are lukewarm at most, but not hot as lava. One side of the moon is permanently in the dark. Do you think this is a myth or a fact? This is a myth. Oh, come on. First the sun, and now the moon. Am I living in a lie? Ha ha. So, people look at the sky and see only the bright side of the moon. The reality is, the sun shines equally on all sides of the moon as it rotates and orbits the Earth. Half of the moon is in shadow, and half gets the sunshine similar to the Earth. That's not true. Similar to Earth, it doesn't have a permanent dark side. The logic is simple. The moon orbits Earth, but it also rotates on its own axis. When you think about it, we're always looking at the same side of the moon. Black holes take in everything that comes their way. What is it, myth or fact? Black holes don't have infinite mass and gravitational force, but still, no one really knows for sure what happens to the things pulled into them. Experts do know black holes do not have supergravity though. Let's imagine this. If there was a black hole as big as the sun, it wouldn't immediately eat the whole planet. Imagine black holes as vacuum cleaners. It does draw in a cloud of dust near its range, but other specks of dust remain where they are. So even if there was a black hole replacing the sun, all the planets would continue to orbit similarly. They wouldn't go into the black hole. If a star or something else got into the range of the black hole, only then would its gravity affect the star. When you call someone, the signal bounces off a satellite. Is this a myth or a fact? It's a myth. Or rather, an urban legend or misconception. You name it. I mean, there are some satellite phones, but we, regular people, don't use those every day. Although your mobile phone works in a much different way. When you call someone, the nearest tower connects you to the other person online. This is why there are tower connections, huge networks of tower-to-tower connections, and hidden cables. The moon has no gravity. Any guesses, myth or fact? This is an urban legend. Ask any astronaut you know. If you don't know any, just trust me. There is footage proving that the moon has gravity. When I say the moon has gravity, don't think it's similar to the gravity on Earth that makes an apple fall. The moon's gravity is only about 1/6 of Earth's. How does it feel to walk on the surface of the moon? The second man on the moon, Buzz Aldrin, mentioned it's like moving in slow motion and perhaps not too far from a trampoline, but without the springiness and instability. The sunset on Mars appears blue. Do you think this is a myth or a fact? This is a fact. Magnificent sunsets. The sky is filled with different shades of yellow. Now imagine this in blue. According to NASA, sunsets on Mars would look bluish. Watching them with bare eyes. It's because of dust. Dust particles closer to the sun appear in blue tones. There is something called moonquakes. Does it sound like a myth or a fact? Fact. Quakes happen on the moon too, and they are called moonquakes. They have different features, not really similar to the quakes on Earth though. A planet can be hot enough to vaporize rocks. Any guesses? Is this a myth or a fact? This is a fact. The temperature in this universe is indeed very high. There's a planet, 55 Cancri E, the temperature of which is enough to melt and even vaporize rocks. It's 2 times bigger than the Earth. This super Earth is similar to our planet, but it is way too hot. Experts believe that it possibly has oceans of lava and clouds that rain molten rock. 1 million Earths can fit inside the sun. Do you think this is a myth or a fact? This is a fact. Although the sun is one of more than 100 billion stars in the Milky Way, which is at the heart of our solar system, it can fit 1 million Earths. Yeah, it looks small when we see it from here, but it's only because it's so far away from Earth. All comets have tails. Myth or fact? It's true. Some comets simply don't show their tails. They look like someone threw a snowball into space. Space is completely silent. What do you say? I know it was too easy. This is a fact. Space doesn't have an atmosphere, so there is no way to hear any sound there. Mercury is the hottest planet. Myth or fact? Mercury is the closest planet to the sun, so this should be a fact, huh? No, not really. Venus is the hottest planet in our solar system, and the second planet from the sun. But the distance from the sun isn't what defines the temperature. The heat depends on the atmosphere. So, Venus's atmosphere consists mostly of carbon dioxide and some nitrogen. This combination makes the atmosphere very thick. When I say thick, I mean it. Throughout the year, the surface of Venus maintains a temperature of around 860 Hrs F. Dutch guys. Mercury's surface resembles the temperature of a desert, but is much higher in terms of temperature variations. Mars has more gravity than Earth. Does it sound real to you? This is a fact. For example, a person who usually weighs around 220 pounds while on Earth would only weigh about 84 pounds while on the surface of Mars. Venus spins clockwise. What do you say? This is a fact. Venus spins in the opposite direction compared to many other planets. The sun rises in the west, and its rotation is very slow. Footprints on the moon can stay there for millions of years. Do you think this is a fact or a myth? Fact checked. The moon has no atmosphere, so there is no wind blowing. Without the wind, there is no way to erase the footprints without any intervention. So, how many points did you get? Let me know in the comments. Hey look, some magical stuff is happening around you. Let's check out some real photos of overwhelming phenomena our Earth offers, and I'll chat about the science behind them. The rainbow-colored scarf cloud is a very rare natural phenomenon. World Meteorological Organization says that this kind of cloud is called pileus clouds. Here's how this rainbow scarf cloud takes shape. There are accessory clouds that depend on a larger cloud system in their development. An accessory cloud widens horizontally and gets shaped like a cap at the top. It attaches itself to the upper part of another cloud. These clouds don't last long, similar in time to a regular rainbow. The main cloud underneath eventually rises and absorbs the rainbow cloud. Who wants to see the ocean glowing and glittering like the sky full of stars? This phenomenon is called bioluminescence. When it happens, waves start sparkling neon blue, thanks to a natural chemical process. Living organisms, such as tiny crustaceans and algae, use bioluminescence to trick predators, attract prey, or find potential mates. Sparkling nightlights have been photographed across Australia and the Indian Ocean. This form of ice is called hair ice. It looks like cotton candy, but it melts away with the sun, not rain. Hair ice is a very unusual phenomenon, and it only forms under specific conditions. It grows on the surface of particular kinds of wood at temperatures below 30 degrees Fahrenheit. If the weather is calm and humid, the hairs can grow up to 8 inches long. In 2015, scientists discovered the fungus responsible for this smooth, silky ice hair. The presence of this fungus leads to a process called ice segregation. The fungus prevents ice crystals from gathering into more stable shapes. I mean, ice can still form on these branches when there's no fungus, but it would be shaped just like normal, not hair-like, ice. So what does this fungus do to make this magic happen? Due to the liquid near the surface of branches is in contact with chilly air. This creates a thin layer of ice. It blends a thin layer of water between the ice and the wood pores. This results in a suction force that pushes the water out of the pores toward the ice at the surface. It freezes there and adds to the existing ice layer. The process repeats over and over. Here you go. Thin hairs of ice are pushed out of the wood. Lake Baikal in Siberia is famous for its crystalline waters. It's the largest freshwater lake on the planet by volume. It contains 20% of Earth's freshwater. It's also very wide. To put it in perspective, it's larger than Belgium.
Plus, it's the oldest lake in the world, about 25 million years old.
And when it freezes during the winter, large shards of transparent ice form on its surface. They appear turquoise because the lake has clear waters. These gem-colored ice structures on the lake's surface are called hummocks. Hummocks are ice splinters. When fierce winds around the lake push its waters into waves, they freeze into these turquoise blocks. Hummocks can be 32 to 39 feet high. Take a look at Naga fireballs. This natural wonder occurs in a specific area around the Mekong River in China. They appear throughout the year, but they're more common during the full moon in late autumn. How they appear is a mystery. These fireballs seem to rise from the water. They can go as high as 985 feet. They are like fireworks, disappearing just as rapidly. They typically have a reddish or orange glow. Did you know that earthquakes emit light too? It turns out that earthquake lights have been around for centuries. They appear before, during, or immediately after an earthquake. They're generally white or blue. The lights rarely last for more than a few seconds, so it's hard to capture them on camera. Yet, on rare occasions, they can shine for up to 10 minutes. Sometimes, they are at the epicenter, while at other times, they're seen up to 250 miles away. They have been spotted over the ocean, too. Scientists know for sure that how powerful an earthquake is somehow influencing this phenomenon. The lights have only been reported during earthquakes rating 5.0 or more on the Richter scale. Scientists have some theories, but it's still a bit of a mystery why the lights exist in the first place. Moonbows have similar principles to rainbows. They occur when the light gets reflected off water droplets in the sky, yet they are much rarer than rainbows. They can appear only under certain conditions. When the moon is very low over the horizon, the sky is dark, and water droplets are in the part of the sky opposite the moon. Halos, also known as circle rainbows, are an optical phenomenon forming high in the sky when the light gets reflected off ice crystals. They look like large circles of white or colored light circling the sun or the moon. The next one is not as rare as the others just mentioned. A sinkhole forms in the ground as a result of some form of collapse of the surface layer. Most sinkholes are caused by the chemical dissolution of carbonate rocks. They're usually circular and vary in shape and size, both in diameter and depth, and you don't want to drive into one of those. A fire whirl is a whirlwind induced by fire. Most of the time, it's composed of flames or ash. This phenomenon is also sometimes called a fire tornado or fire twister. It's pretty clear how it got this nickname. It looks like a tornado, and it's made of fire. Yet these terms usually refer to a separate thing, where a fire has such intensity that it creates an actual tornado. Fire whirls are different. They don't usually count as tornadoes, as the vortex doesn't extend all the way from the ground to the cloud base. Lenticular clouds are usually in parallel alignment to the wind direction. They have a particular shape. I mean, look at it. That's what people imagine when they think about a spaceship of visitors from outer space. I'm at shot wages and guess mean. Many people dream of witnessing this one. The Aurora Borealis, or the famous Northern Lights. It's a free natural light show in the sky. Charged particles from the sun strike atoms in Earth's atmosphere. Then they cause electrons in these atoms to change to a higher energy state. Eventually, the electrons get back to a lower energy state. That's when they release photons of light. Obviously, Nordic countries are the best places to see this show. But hey, you can see the Northern Lights in Scotland too. The Morning Glory Cloud is a very long rolled cotton-like cloud. It's seen occasionally in various parts of the world. But there's one place on our planet where they occur on a regular basis. It's the Gulf of Carpentaria in northern Australia. These clouds can stretch for 620 miles. Plus, there can be more than one morning glory cloud at one time. So far, we have seen moonbows, halos, and many other phenomena. But how about looking at a fire rainbow? The fire rainbow is much easier to say, but the real name of this thing is a circumhorizontal arc. Say it with me. Circumhorizontal arc. Very good. It's another cool optical phenomenon that occurs in cirrostratus clouds. Check this out. The next two cool facts are related to animals. What would you do if 1,000,000 butterflies flew over your head? This might happen when you see monarch butterflies while they're migrating to Mexico or Southern California. These butterflies cannot cope with cold winters, nor can I. So, every fall, they migrate either to the south or west, where it's warm all year long. This is a field completely covered with spider webs. This phenomenon only occurs when spiders flee from floods or some other kind of natural disaster. When they leave, they find a higher place to spin their webs. Usually, such a place is a tree or an agricultural field. Since many of them gather in the same safe region, they all make their webs at the same time. Doesn't this huge spider web look like a thick blanket? Yeah, you go lie down in that. Just kidding. Have you ever come across unique natural phenomena? Comment below and let me know. It's the year 2031, and the first human has just set foot on the red surface of Mars. It was a long flight that lasted 172 days. It was a tough journey. There were lots of technical issues. There were some physiological obstacles. Astronauts had to deliver tons of equipment and energy generating and life-supporting systems to the red planet. Those responsible for the mission had to understand how to deal with low-pressure atmosphere and catastrophic sandstorms, how to keep people safe on Mars's surface, and how to bring them back to Earth after their work is done. It does sound like a science fiction story, but soon, it's going to be our reality. But the coolest thing? It's not the limit. After exploring Mars, people might set even more ambitious goals, and this is what some of them may look like. The next planet to visit could be Venus, but it would be a challenging task. Venus is also called the morning or evening star. all because it shines so brightly in Earth's sky that it's the first one to appear after sunset and the last one to vanish after sunrise. But in terms of exploration, Venus is very unfriendly to humans. Its atmospheric pressure is about 92 times as great as the pressure on Earth. And the temperatures on its surface
On average, 850 degrees Fahrenheit.
Modern technologies wouldn't allow us to build an infrastructure that would allow people to survive on the planet for longer than a couple of minutes. But then, why would we set sail for Venus? Here's a curious thing. At the height of 30 to 40 miles above the surface of the planet, there are the most Earth-like conditions in the entire solar system. The pressure there is almost the same as in the mountains on Earth.
And the temperatures range from 70 to 85 degrees Fahrenheit.
If the planet's atmosphere was made up of oxygen and not toxic gases, we could live there without any additional equipment. Or, we could go to Phobos and Deimos. Those are Mars' moons. It would be the first time humans set foot on the moon of some other planet. Phobos is located a mere 3,700 miles away from the surface of the red planet. It would take no longer than a day to reach it. This potato-shaped piece of rock is quite small, a mere 13 miles across. This is the reason why it has very weak gravity. Deimos is a bit farther away from Mars, about 15,000 miles, but this mini-moon is even smaller than Phobos. It's a bit more than 7 miles across. In other words, visiting these moons wouldn't be unlike landing on an asteroid, and the greatest challenge astronauts would face would be leaving the surface of Mars. To do it, they would need loads of fuel. So, most likely, the first trips to Phobos and Deimos would be launched from space stations orbiting Mars. We could set an even more ambitious goal and head for Jupiter and its moons. The distance between this gas giant and our home planet is 365 to 600 million miles. This distance can be so different because the planets follow their elliptical orbits around the Sun, getting closer, then farther apart. The minimal distance occurs every 13 months. If people set off on this long journey during this period of time, it would still take them about 2 years to get there. Since Jupiter is mostly gas, on-planet exploration wouldn't be possible. We could probably fly around the largest planet in the solar system and even dive into its atmosphere. But much more interesting for exploration objects would be Jupiter's moons. Let's say Europa. This natural satellite has a water ice crust. It can be from 10 to 15 miles thick. Under this crust, there might be liquid water. The core of the moon might consist of liquid metal inside a rocky shell. Its super-thin atmosphere contains some oxygen. Considering all this, it would be a rather comfortable place for people to explore, if not for its temperature.
It doesn't rise above 240 degrees Fahrenheit.
We could visit another Jupiter's moon that is called Ganymede. It's an ice satellite with a very thin atmosphere that contains oxygen, or Callisto. It's the second largest among Jupiter's moons. Its icy crust is about 124 miles thick, and it's very cold on the moon.
Around 220 degrees Fahrenheit.
People could also send an expedition to Saturn and its moons. For example, Titan or Rhea. The gas giant itself is twice as far away from Earth as Jupiter. It means it would take astronauts more than 3 years to get to this planet. But if the spaceship was launched from a space station on Mars, it could reduce the travel time by 25 to 50%. But even if the starting point of this expedition was Earth, with advanced technologies like nuclear thermal propulsion, such a journey could take just a year or even less. Saturn can't be explored directly, so researchers would probably start with its largest moon, Titan. It's also the second largest moon in the solar system. This natural satellite has an atmosphere that mostly consists of nitrogen. The pressure on its surface is twice higher than that on Earth. There are winds and rain, on Titan, lakes, and rivers. But those consist of liquid ethane and methane rather than water. It's actually a good thing. We'd have a lot of resources to produce fuel and energy. Rhea is the second largest of Saturn's moons. It's made up mostly of water ice. Its atmosphere is super thin, but it also has some oxygen in it. Actually, all the largest moons of Saturn have only one serious drawback. It's freezing cold there.
On the bright side, they all have plenty of resources to produce energy and other life-sustaining elements, and it would be much easier and faster than the same process on Mars.
But what if we could explore exoplanets? Those are planets that travel outside our solar system. If we managed to get so far away from Earth, maybe we would reach some potentially habitable worlds. It could be Proxima Centauri b. It's the closest to Earth exoplanet, and recently, astronomers have found out that this world might resemble Earth even more than they previously thought. It's only 17% more massive than our home planet. It orbits a star that is dimmer and less massive than the Sun.
Proxima Centauri b is in the middle of the star's habitable zone.
This means that the chances are liquid water and life might exist on the planet. It looks like the exoplanet is tidally locked with its parent star. It means one of its sides faces the star at all times, and the other is always in the darkness. Scientists haven't figured out yet whether the planet has an atmosphere. It's traveling too close to its star, so the radiation from the star might be pulling the planet's air away. If this is the case, Proxima Centauri b isn't likely to have liquid water on its surface. It would take way longer to reach potentially habitable Gliese 832c. This exoplanet is 16 light-years away from Earth. In the cosmic scheme of things, it's a stone's throw away. Gliese 832c is 5 times as massive as Earth, and travels much closer to its parent star. That's why a year on this planet lasts a mere 36 days. But since this parent star is a red dwarf, it's much cooler and dimmer than the Sun. So, Gliese 832c gets as much light and heat as our planet does. At the same time, it's still unclear if Gliese 832c is similar to Earth. It probably has a much thicker atmosphere that creates a runaway greenhouse effect. This phenomenon occurs when a planet absorbs more heat from its host star than it can release back into space. This means that unfortunately, Gliese 832c is more likely to resemble scorching hot Venus rather than relatively cool Earth. The legend of the Black Knight satellite tells us that a spaceship of extraterrestrial origin has been orbiting Earth for many, many years. Sounds crazy, right? But over the years, the supporters of this theory have gathered a lot of evidence to prove it. So, let's look at it and judge for ourselves. 1899, famous scientist Nikola Tesla built a giant tower in his laboratory in Colorado Springs. This tower was supposed to allow him to study atmospheric electricity and wireless energy. Everything went fine until one day, he discovered something unexpected. The tower began to catch a signal that seemed to be artificial. At first, Tesla thought that the signal was coming from somewhere in the atmosphere, but it turned out that it had been coming from an even greater height, from outer space. Tesla decided that this signal was sent by some extraterrestrial life. However, the scientific community ignored his theory. Although they respected Tesla's genius, they still considered him to be a weirdo. But a few years later, Tesla's reports were confirmed. The inventor of the wireless radio, Guglielmo Marconi, intercepted similar signals. Then, in 1927, Norwegian radio engineer Jürgen Hals noticed something unusual. When he sent signals at a certain wavelength, they were sent back to him a few seconds later. At first, he thought it could be an ordinary radio echo. It's not uncommon for short radio waves to bounce between Earth and the stratosphere. This phenomenon is called propagation, but usually this happens very quickly, in about 1/7 of a second after the original transmission. transmission. However, the signals that Halls received took about 15 seconds to get back. They also didn't match the radio echo people were used to. The engineer wasn't the only one to witness this phenomenon. Many radio enthusiasts discovered and confirmed these signals, but no one found any explanation. So, what was it? Could Tesla have been right this whole time? Let's unpack this. First of all, the signals did exist, and they've been documented by many people. However, Tesla and Marconi's signals and Hall's echoes are completely different things. In reality, Tesla and Marconi caught signals coming from pulsars. Pulsars are rapidly rotating neutron stars. Those get born when stars greater than our sun finish their life cycle. After that, they become neutron stars and receive such a strong impulse that they begin to rotate at an insane speed. At the same time, the radio waves pulsars emit reach very far as our planet. Pulsars were discovered only in 1968, so it's not surprising that Tesla and Marconi couldn't explain the data they had received. But what about Jürgen Halls? What he discovered is now known as LDEs, or long-delayed echoes. It's a more complicated concept because, to be honest, these echoes still remain a mystery. Scientists suggest that LDEs may be caused by something in Earth's atmosphere, or they might be reflected from the sun's plasma, clouds, or even from the moon. Unfortunately, we don't know the truth yet. The next incident took place in 1960. The New York Times published an article which said an unidentified silent satellite has been discovered circling Earth in a near-polar orbit by United States tracking stations. The identity and origin of the mysterious satellite, which has been dubbed the Dark Satellite, are unknown despite nearly 2 weeks of tracking. Many people believe that this must be the famous Black Knight satellite. However, later, scientists confirmed that it was actually the remnants of a regular satellite that had gone astray. It malfunctioned, and the thrusters sent it in the wrong direction, they claimed. Anyway, this whole story led to renewed interest in the Black Knight satellite. Astronomers all over the world started claiming to have observed it. Almost any strange celestial object could become the famous dark spaceship. But up to this point, all the photos and data about the Black Knight satellite have come from observatories on Earth. To prove or disprove its existence, people needed some witnesses in orbit. Gordon Cooper was a pilot and one of the first astronauts in human history. In 1963, he took part in the longest American space mission at that time, Mercury Atlas 9. During the flight, he discovered some strange green object, possibly of extraterrestrial origin, in front of his module. He then told his crew on Earth about that. NBC News picked up on the news and tried to interview Cooper about it, but strangely, neither NASA's mission transcripts nor Cooper seemed to give much importance to this fact, as if that didn't happen at all. Later, the official NASA's explanation was, there was an electronic malfunction on Cooper's craft. It led to increased levels of carbon dioxide, which in turn caused Cooper to hallucinate. Cooper agreed with this version. Maybe it's just a curious coincidence that when he retired, he became interested in searching for extraterrestrial life. But even if we assume that all this is true, and there is some mysterious spaceship in Earth's orbit, what do they want from us? Why would they be watching us? In 1973, Duncan Alasdair Lunan, a Scottish researcher, decided to investigate this. He gathered all the data on LDEs collected by Norwegian scientists and began to study it. Suddenly, he noticed some deviations that could hide a code. He arranged the data into a graph, where one axis meant the delay in time between the echoes, and the other the position of the echo in the sequence. It turned out to be a collection of dots, which looked like some sort of a space map, namely the map of the constellation Boötes. Lunan began to analyze the echoes recorded by French astronomers in 1929. Again, he got the same constellation, but one of the stars was in a slightly different place. Lunan then thought, what if it's actually a star map from the past? After rewinding the time, Lunan finally got the whole picture. He discovered that this was how the constellation looked 13,000 years ago, which probably meant that they could have been watching us for thousands of years. In 1973, Lunan gave an interview to the British magazine Spaceflight. He said that he had deciphered the radio message hidden in the LDEs. Here's what it said: "Start here. Our home is Upsilon Bootis, which is a double star. We live on the 6th planet of 7, coming from the Sun, which is the larger of the two. Our 6th planet has 1 moon. Our 4th planet has 3. Our 1st and 3rd planets each have 1. Our probe is in the position of Arcturus, known in our maps. Ugh, goosebumps. But even though these reports were published in the New York Times, Time, and other well-known magazines, no one really took this topic seriously. Unfortunately, Luhnin's theory wasn't really backed up by any evidence. Later, he withdrew it himself, saying that he had made obvious mistakes and that his methods had been unscientific. According to him, he had just been making guesses about what these signals might mean. And finally, the last part of our story, this photo. On December 4th, 1998, the Endeavour spacecraft embarked on the STS-88 mission. This was the first mission to the International Space Station. And then, on December 11th, NASA took and published a series of images where you could clearly see an unusual object in Earth's orbit. These photos were immediately picked up by the public. Everyone thought it was the Black Knight satellite, which had been discussed for years. Had it finally been found after 100 years of speculation? But, as usual, the truth turned out to be much more boring. During the mission, one of the astronauts was installing a thermal cover, but the coating was poorly fixed. It broke off and flew away. The photos were taken just to document this event. The Black Knight is a very interesting legend. You can dig into it for hours, looking for new information and evidence, and then watch it getting debunked. This story is a pileup of many completely unrelated stories, reports, photos of real satellites, and so on. All this was mixed into one incoherent, illogical urban legend. Illogical, but very fascinating indeed. Imagine a being so powerful, it can suck in entire galaxies, so mysterious, it's invisible to the naked eye, and so impressive, it bends the very fabric of space and time to its will. Yes, meet my mother. Just kidding. Actually, meet the ultimate superhero of the universe, the Black Hole Star. What is it, and how does it work? The universe is full of marvels, and the Black Hole Star is one of the most impressive ones. It's a supermassive force that can bend the laws of physics, and a true enigma for scientists to unravel. No wonder science fiction writers find them so captivating. A black hole star, also known as a quasi-star, is a hypothetical type of extremely massive and luminous star that may have existed early in the history of the universe. They're predicted to be as luminous as a small galaxy, but unlike modern stars, they weren't powered by nuclear fusion in their cores. A quasi-star's energy would come from material falling into a black hole at its core. And yes, just like a normal black hole, these stars have the power to suck in anything and everything that gets too close, including stars, dust, and even entire galaxies. But how is it possible that the star is born from a black hole? And what's more, how do they continue to coexist together? Well, first, let's discuss how black holes are born in general. It all starts with a supermassive star, one that is at least a few times more massive than our own sun. This giant of a star burns bright and hot, shining with the light of 1,000,000 suns. But eventually, it runs out of fuel and its fate is sealed. As its lifespan comes to an end, it makes one final, massive boom. A blast so powerful it can outshine an entire galaxy. This blast is called supernovae. During this boom, the outer layers of the star fly away, while the core gets squished together by its own gravity. If the squished core is heavy enough, it can keep squishing until it becomes a black hole. And just like that, a black hole is born! Don't even try to put diapers on this thing. Now, this cosmic monster baby can continue to grow by swallowing up anything that gets too close, including stars, dust, and even entire galaxies. This is basically what's happening now in our universe, with supermassive stars. But what about quasi-stars? The formation of a quasi-star could only happen early in the development of the universe, before hydrogen and helium were contaminated by heavier elements. And because of that, quasi-stars have one important feature. They are gigantic. They may have been dwarfing even the largest known modern stars like VY Canis Majoris and Stephenson 218. No wonder they're so scary. They were born from protostars, one of the first stars in the universe, the great-great-grandfathers of, you know, everything. So now imagine a protostar so massive that its core collapses into a black hole, just like we described before. But the key difference is that in a regular supernovae, the outer layers of the star are blown away by the energy released during the boom. Meanwhile, in a quasi-star, these outer layers are massive enough to absorb the energy without being blown away. What do we get in the end? A star with a black hole in its core that weighs from 1,000 to 10,000 solar masses. This quasi-star is about 14,000 times bigger than our Sun, which makes them bigger than any star we know today. Once a black hole is formed at the center of a giant protostar, it starts to give off a ton of energy. This energy helps to balance out the force of gravity, making it kind of like a giant fusion-based star. They would be so bright that each one would look like a small galaxy. Quasi-stars would have a pretty short lifespan, around 7 million years. Just for comparison, our Sun is about 4.5 billion years old, and it's only halfway through its lifetime. But either way, during this short period, the black hole at the center would grow to be about 10,000 times the size of our Sun. Quasi-stars are also thought to be super hot, with temperatures reaching over 17,500 degrees Fahrenheit. But as a quasi-star gets older, it starts to cool down, and its outer layers become see-through. Eventually, it cools down to a temperature of 6,740 degrees Fahrenheit, and at that point, it's curtains for the quasi-star. It can't survive at that temperature, so it just dissipates, leaving behind an intermediate mass black hole. Unfortunately, right now, there's no observational evidence for the existence of quasi-stars. This is because they are thought to have only existed a very, very long time ago. They may have been very massive population 3 stars, which are extremely rare and difficult to detect. It's also very unlikely that any of them would still exist today because of their super short lifetime, only 7 million years. So why do scientists believe that quasi-stars could have existed? Because they're looking for ways to explain how supermassive black holes formed so early in the history of the universe. They're found at the center of most galaxies. But how could these monsters have formed so quickly? After all, it takes a really long time for small black holes to grow into supermassive ones. This is where the idea of quasi-stars comes in. These stars aren't just destructive forces of nature. They're like the black belts in the martial art of gravity. They can bend and twist anything to its will. That's why these stars, if they really existed, had to play a crucial role in the evolution of galaxies. They must have been instrumental in shaping the universe as we know it. So, those intermediate-sized black holes that they left behind could eventually turn into supermassive black holes in the centers of galaxies. But we're still yet to solve this cosmic mystery. Detection and study of black hole stars is like trying to find a needle in a haystack, only instead of a needle, it's an invisible and mysterious object, and instead of a haystack, it's the vast expanse of space. But with the help of some pretty cool technology and a lot of brainpower, scientists are getting closer to uncovering the secrets of these celestial giants. Here are some things that can help us in this research. First of all, gravitational waves. They're like ripples in the fabric of space-time caused by the movement of massive objects. Albert Einstein predicted them way back in the 20th century, but they were finally detected only in 2015. We caught them by observing the collision of 2 black holes. This discovery confirmed that black holes can merge, and that they're a powerful source of gravitational waves. Scientists think that by studying these waves, they can learn more about how black holes form and grow. Right now, they use a special space probe, LISA, to study them. By combining the information from LISA with other observations, scientists hope to learn more about these terrifying celestial objects. We can also try to detect quasi-stars by observing the effects of their gravity on nearby objects. And, of course, we can use our technologies, such as X-ray, infrared, and radio telescopes. This allows us to study black holes in various ways and at different stages of their lives. In other words, scientists are working hard to uncover the secrets of these celestial giants. We develop new telescopes, search for primordial black holes, and try to understand the connection between black hole stars and dark matter. And we're making some pretty incredible discoveries, just like with gravitational waves. And when we find out the truth about them, it will become a new page in our scientific history. Imagine leaving your house one morning and seeing not one, but two stars shining in the sky. The first one is our good old sun, and the other is Jupiter. But how is a planet turned into a star? And what will now happen to Earth and its inhabitants? Before we find the answer to these urgent questions, we need to revise some things we know about Jupiter. The largest planet in the solar system is a gas giant, which means it's made up mostly of gases. Due to the pressure and temperature differences, these gases separate into layers. This creates those red and white bands that can be clearly seen from Earth. The temperatures at the top of Jupiter's atmosphere are insane. They can reach a whopping 1,540 F. The planet also has an immense gravitational pull. In 1995, the Galileo probe reached the atmosphere of Jupiter and sliced it at a speed of 106,000 mph. It survived the scorching temperatures and started its descent. It kept moving even when the temperature suddenly dropped and the pressure, as well as the speed of the wind, increased. But 58 minutes and 97 miles into its exploration, things went downhill. The pressure of 23 atmospheres and still high temperatures finished the probe off. It was melted and then vaporized by the extreme heat. Now, if Jupiter suddenly decided to keep growing, it would eventually become a star, and its composition would allow this planet to do it. Once, a long time ago, Jupiter took most of the mass that was left after the formation of our Sun. That's how it ended up with more than twice the combined material of all other bodies in the solar system. And the planet's ingredients are the same as those of a star, mostly hydrogen and helium. Jupiter is just not massive enough to ignite. Then, it would turn into another kind of celestial body, most likely a brown dwarf. In this case, it would have a minor effect on the orbits of the planets of our solar system, because brown dwarfs are more massive than planets, but not as massive as stars. A brown dwarf is usually 13 to 80 times the mass of Jupiter. It can only become a star if the pressure in its core gets high enough to start nuclear fusion. So, let's imagine that it's happened, and Jupiter has become a real star, for example, a red dwarf. Red dwarfs are stars with masses around 7.5% to 50% of the mass of our Sun. Red dwarfs are also hotter than brown dwarfs. Their temperature can reach 6,380 IPF. Our Sun, by comparison, has a temperature of almost 10,000 AF. So, it means that the newly formed red dwarf will be far dimmer than the Sun. And still, red dwarf Jupiter could prevent the inner planets from following their orbits, because they wouldn't be able to find a balance between the gravitational forces of the two stars. The planets would move either closer to the Sun or closer to the newly formed red dwarf. If Earth chose the first option, our main star's insane temperatures. If it was the second scenario, we would probably freeze, since Jupiter, as a dim red dwarf, wouldn't be able to warm us up well enough. But there could be one more option. The inner planets could get thrown out of the solar system altogether. If Jupiter was a star, it would also greatly increase the amount of radiation the surface of Earth would receive. Our atmosphere would have to protect us both from the radiation coming from the Sun and from Jupiter's radiation. Red dwarfs are notoriously active. That's why Jupiter, just like the Sun, would most likely have frequent coronal mass ejections. This is a fancy expression for describing large clouds of electrically charged particles a star releases with a huge burst of speed. Even now, Jupiter has a significant impact on our planet. The gas giant is roughly 318 times as massive as Earth, and this also means it has an outsized pull on our planet. Its gravity can cause shifts in the orbit of our planet and climate swings every 400,000 years or so. When Jupiter's influence is the strongest, Earth usually has colder winters, hotter summers, and more intense periods of wetness and droughts. Also, if Jupiter turned into a red dwarf, its most prominent feature might probably disappear for good. I'm talking about the Great Red Spot. It's an enormous storm raging in the southern hemisphere of the gas giant. Its top parts tower more than 5 miles above the tops of the surrounding clouds. The storm is almost twice as wide as our planet. In 2017, NASA's Juno space probe managed to collect lots of data about the red spot, and it turned out that this monster of a storm went more than 200 miles down into the planet's atmosphere. That's 30 to 100 times deeper than any ocean on Earth. But these measurements are most likely imprecise, and the storm's true roots can be reaching even deeper. The Great Red Spot is colder than the rest of the atmosphere. And keep in mind that Jupiter's temperatures are 280 RF in the upper cloud layers. On the other hand, the closer to the core, the hotter it gets. Mysteriously, the highest temperatures ever recorded on the gas giant occurred in the atmosphere right above the Great Red Spot. They were higher than the temperature of lava on our planet. Astronomers believe that the turbulence caused by the storm might produce gravitational and sound waves that can be responsible for the superheating. But the storm itself is warmer at the bottom than at the top. People have been watching the moving vortex on Jupiter for more than 150 years. Some time ago, astronomers predicted that it would gradually slow down and become smaller or disappear altogether. But that turned out not to be the case. After having analyzed all the data received with the help of the Hubble Space Telescope, researchers were baffled to discover that the winds at the outer boundaries of the storm had actually picked up speed. Oh, that's faster than Earth's tornadoes. At the same time, if you found yourself at the center of the Great Red Spot, you wouldn't be too impressed. The winds there move way more slowly. And now, I have another what-if situation for you. What if Jupiter collided with the smallest star we know about? Today, these two space bodies are on a collision course. A spoiler, Earth might not survive such an encounter. Okay, meet this tiny red dwarf, EBLM J-South 557AB. It's the size of Saturn, and its gravity is around 300 times the gravity of our planet. It normally floats 600 light-years away from Earth in a double-star system, but today, for some inexplicable reason, it's broken all the laws of the universe and is rushing toward the biggest gas giant in our solar system. And even though this space guest is smaller than Jupiter, its mass is way greater, and its gravitational force soon starts to pull on the gas giant. The heat from the red dwarf plus its powerful gravity makes Jupiter grow in size. The planet's atmosphere starts to puff up because the gases that make up the planet begin to heat up and expand. Jupiter's atmosphere starts to leak into space toward the stellar visitor. Sometime later, the runaway gases form a bright hot ring around the red dwarf. This is a terrifying view, as if a black hole, a very bright one, has appeared inside the solar system. The star keeps tearing Jupiter apart, eating chunks of the gas giant, and soon, the red dwarf engulfs it completely. Sadly, Jupiter never stood a chance. Instead of the gas giant, we now have a red dwarf surrounded by a ring of hot gases, and we already know how badly it may end. The best thing about it is that this scenario is totally imaginary. Phew, thank goodness.